Hello and welcome to the session on SURDs. What are we going to learn in this session? First, we'll understand what are SURDs. Then we'll understand how do we simplify SURDs. And finally, we'll also learn how do we perform calculations on SURD with a special type of calculation called rationalization towards the end of the lesson. Okay, so let's begin then. What do we understand by this term SURD? To figure that out, okay, let's take some real life examples. Can you find the length of this square, the area of which is 10 centimeters squared? Or for that matter, in this case, okay, these are the paper sizes, which are very standard paper sizes, okay? For example, A4 paper size uh, is the paper size which you put into the printer, right? You get the printouts. A3 is the poster size, okay? So what is the ratio of the height and width of each of these paper sizes? Okay, for your benefit, okay, we have given you the height and the width, okay, and for each paper size. So you can use a calculator, punch these values and find out, okay, what do you get? Okay, the same is the case with the one on the left, the example on the left. The area is 10 centimeters squared. Can you find out, okay, what is the length of the side of that square? Right, length of the side is square root of the area. So go on, take your time and try to find out, okay, how much is the answer for each of those cases, right? If you have found the answer, you would realize that they are not proper numbers. Okay, the answers are not proper numbers. Okay, you would have either got a decimal, which is okay non-terminating. Okay, it goes on and on and on. Or you would have got a strange sign, okay, square root sign. For example, the answer to the first question is square root of 10. Okay, each side of the square has to be square root of 10. And in the second case, the ratio of the height to width in each of the three paper sizes is square root of 2, right? Now it is these special numbers, square root of 10, square root of 2, which are called as surds. Okay, so let's understand what are surds. Okay, the definition of surds is a surd is an expression that includes a square root, a cube root, or any other root symbol, right? So any square root of a non-perfect square or a cube root of a non-perfect cube is a surd. Okay, so I'll give you a list of numbers. Can you identify which of these numbers actually qualify to be a surd? Okay, let's take the first one. Square root of 10. Is 10 a square number? Okay, 10 is not a square number, which means that is a surd. Remember, the definition of surd says it's a square root of a non-perfect square. Okay, a square root of a number which is not a square number. What about 36? Okay, 36 is a square number. So square root of 36 is actually 6, which means that the second number is not a surd. That doesn't qualify as a surd. Square root of 24. Is 24 a square number? No, which means that is a surd. Okay, let's look at the cube roots now. Cube root of 5. Is 5 a cube number? No, right? So cube root of 5 is a surd. What about cube root of 8? 8 is a cube number. 2 cubed is 8, which means cube root of 8 doesn't qualify as a surd. And finally, cube root of 12. Is 12 a cube number? No, right? Which means cube root of 12 also doesn't qualify. It qualifies as a surd. My bad. Okay, cube root of, because 12 is not a cube number, so it qualifies as a surd, right? So surds are square root or cube roots of numbers which are not perfect square or not perfect cubes, respectively. Okay, surds are used to write irrational numbers. Remember, we did irrational numbers. Irrational numbers are numbers which are non-terminating and non-recurring, right? Because such numbers cannot be written in exact form, so we use surds to write them in the precise manner. So if you can read the definition, it says surds are used to write irrational numbers precisely. Because the decimals are of irrational numbers are non-terminating and non-recurring, they cannot be written in decimal form as an exact value. So we use surds to write their value. Okay, for example, if you type in the calculator square root of 10, okay, you would get a series of decimals which are non-terminating, right? So instead of that, in a simple form, you can write square root of 10. That's much easier way of writing it. Well, you understood what are surds. So let us now understand how do we multiply or divide surds. Okay, now these are simple rules. Square root of a times b is actually square root of a multiplied by square root of b. By the same logic, square root of a divided by b is the same as square root of a divided by square root of b. For example, square root of 2 times square root of 3 is actually square root of 6, right? Because 2 times 3 is 6. So square root of 2 times square root of 3 is square root of 6, right? That seems the easy rule to remember, right? What about division? Okay, square root of 8 divided by square root of 4. Because 8 divided by 4 is 2, it is actually square root of 2. Okay, let's take a complicated example. Square root of 5 multiplied by square root of 10 divided by square root of 2. Let's look at the numbers first. Okay, 5 times 10. How much is 5 times 10? 50. 50 divided by 2, 25. So that is square root of 25. And square root of 25 is actually not a surd. Remember, 25 is a perfect number, perfect square. It's a square number. So square root of 25 is 5. So that's your final answer, right? Now, once I understand this rule, then the next rule is quite interesting. Okay, if you look at this, square root of 7 times square root of 7. So if I have two surds which are the same values, when they are multiplied to each other, square root of 7 times square root of 7, what do we get? As you can see, 7 times 7 is 49. So square root of 49 is actually 7, right? So which means square root of 7 times square root of 7 is 7. Okay, which means I can generalize that as square root of x times square root of x is x, right? So remember that rule, x square root of x times square root of x actually is x, right? Now, why did we learn how to multiply and divide surds before any other calculation? Because to simplify surds, we need this particular skill. Okay, so let's understand how do we simplify surds. To simplify surds, we need to write the number inside the root sign as a square number multiplied by any other number. Okay, please understand this carefully. The number inside the square root sign should be written as a square number multiplied by any other number. Okay, square number could be any of those numbers which you are aware of. Okay, 4, 9, 16, 25. Remember, these are square numbers. Okay, so let's take an example. Square root of 50. Now, can 50 be written as a square number multiplied by another number? Think about it. Can you write 50 as a square number times any other number? Think of all the square numbers. Okay, some of them are given up there on the right, 4, 9, 16, 25. So is 50 a multiple of any of those? Yeah, 25, right? So we can actually split 50 as 25 times 2, right? So square root of 50 can be written as square root of 25 multiplied by square root of 2. So square root of 25 multiplied by square root of 2. What's square root of 25? Square root of 25 is 5, right? And square root of 2, that's a surd. So we cannot split that. So we have to write it as it is, right? So finally, what we get is 5 multiplied by square root of 2, which is 5 root 2. And that's your simplified form. So square root of 50 can actually be written as 5 root 2. Okay, that's what is called simplifying surd. Okay, so we started with square root of 50, and if you see, we ended up at 5 root 2. Okay, that's the simplified form of square root of 50. Okay, let's understand what is not a good way of simplifying surd. Okay, so we'll use that, we'll understand that using this example of square root of 80. Now, this is where typically many students, okay, go wrong. They don't simplify it properly. So we'll understand which is the correct way of simplifying square root of 80. Okay, But first, let us understand which is not the correct way of simplifying square root of 80. So split square root of 80 as a square number multiplied by some other number. Think about it. Now the easiest thing that comes to my mind is, okay, 80 is 4 times 20, where 4 is a square number. Remember, 4 was one of those square numbers, right? So 4 times 20. So that can be written as square root of 4 times square root of 20. Square root of 4, as you know, is 2, right? Root 4 is 2. And square root of 20 can be written the same way. So your final answer is 2 root 20. But there's a small problem here. If you look at the number inside the root sign, which is 20, can be further split into a square number times another number, right? Because 20 itself is 4 times 5, right? Which means this is not the right way in which we can simplify SURD, because we have not simplified it completely. Because right now, 2 root 20, square root of 20 itself can be split as a square number times some other number, right? So we have not simplified it completely. So what's the correct way of simplifying square root of 80? Or for that matter, correct way of simplifying any other SURD. Okay. Now think of the biggest square number that is a factor of 80. Okay, 4 is one square number, which is a factor of 80. So we split that as 4 times 20 earlier, but that's not the biggest square number, which is a square root of 80, which is a factor of 80. Okay, the biggest square number, which is a factor of 80, is 16. Right? So the best way to split 80 is 16 times 5. 16 times 5 is 80. Okay, and now we can go ahead with our simplification. 16 times 5 can be written as root 16 times root 5. What is square root of 16? Square root of 16 is 4. Okay, we write square root of 5 as it is. So your final answer is 4 root 5. And as you can see, root 5 cannot be split further. Okay, root 5 is the simplest possible form of the SURD. And hence, this is the correct way of simplifying. Okay, we have completely or fully simplified square root of 80, right? So where was the catch? Okay, where did we go wrong in the first case and we corrected it in the second case? The idea is not simply to understand, okay, not simply to write it in the square number times any other number. The square number which you write has to be the biggest possible square number. Okay, so 4 times 20 is good, but 16 times 5 is better. Okay, 16 is a bigger square number, which I can split 80 into, right? So make sure that you understand that thumb rule, right? Well, now let us understand how do we add and subtract SURDs. Okay, the good thing is you can add or subtract SURDs, but only if they are having the same root part. The square root part has to be the same. For example, let's start with these easy examples. Okay, 3 square root of 5, 4 square root of 5. So they have the same root part. Okay, similarly, 8 root 3 minus 3 root 3, same root part, right? So how do we do that then? We add or subtract the number part and leave the third part as it is. Okay, so we add or subtract the number part, which means 3 plus 4 is 7. And in the second case, 8 minus 3 is 5. Okay, so only the number part needs to be added or subtracted. And the third part needs to be left as it is. So in the first case, square root of 5 is left as it is. And the second case, square root of 3 is left as it is. And that's your answer. Okay, so first answer is 7 root 5. The second answer is 5 root 3. Okay, sounds simple, right? But the thumb rule was this could have been done only because the square root part for both the numbers were the same. What if they are not the same? Okay, special cases. Okay, like in this case, square root of 12 plus square root of 27. Can we add them first of all? Not in the current form, right? Square root of 50 take away square root of 18. Again, in the current form, we cannot subtract them. So what do we need to do? Okay, let's understand. Let's simplify SURDs. Remember, we learned how to simplify SURDs. So 12, how can you break it into a square number times some other number? 12 can be broken down as 4 times 3. and 27 can be broken down as 9 times 3. Correct? So we can break down square root of 12 as 4 times 3 and 27 as 9 times 3. Okay, square root of 4 is 2 and square root of 9 is 3. So square root of 12 can be simplified as 2 root 3 and square root of 27 can be simplified as 3 root 3. And now both of them have the same root part, as you can see. So we follow the same rules. We add the numbers 2 and 3, which is 5, and write the root part, which is the third part, the same way, okay, as it is root 3. So your final answer is 5 root 3. So as you can see, we started with square root of 12 plus square root of 27, which seemingly could not have been added. But when we simplified them, okay, we realized that, okay, they had the same root part, and hence we went ahead and added them. Can we do something similar for the second example? Okay, so let's try and simplify square root of 50. Remember, we did that earlier, square root of 50. So can be split as 25 times 2, and 18 can be split as 9 times 2, right? Square root of 25 is 5. So root 50 can be written as 5 root 2, and square root of 9 is 3, right? So that square root of 18 can be written as 3 root 2. Now, as you can see, both of them ended up having the same root part. So 5 root 2 minus 3 root 2, you subtract the number part, 5 minus 3 is 2, and you write the root 2 as it is. So your final answer is 2 root 2, right? And finally, before we end the session, let us understand this interesting calculation called rationalizing denominator. Now, what is to rationalize denominator? When we rationalize denominator, we get rid of the third part in the denominator by changing it into an integer. Okay, let me repeat again. You get rid of the third part. Third part is the root part in the denominator by changing it into an integer, right? It looks complicated, but let's take an example. You'll understand it. So let's say we have this square root of 2 divided by square root of 3. Now, if you look at the denominator carefully, that has a root in it, square root of 3, right? It's a third. So we need to get rid of that by converting it into an integer. Now, how can we do that, right? Now, did you remember the rule where we had square root of x times square root of x is x, right? Right in the beginning, we had learned that rule. So the best way to do that is you multiply the denominator by another square root of 3. Okay, you multiply it by square root of 3. But by doing that, the fraction would be disturbed, right? If I only multiply the denominator by square root of 3, the fraction will not have the same value. So to compensate that, I need to also multiply the numerator by square root of 3. So that's what is a process of rationalization. You multiply the numerator and denominator by the denominator. Okay, the denominator was square root of 3. So you multiply both numerator and denominator by the denominator, which is square root of 3. So what do we get? Numerator, as you can see, square root of 2 times square root of 3 is square root of 6. And the denominator, square root of 3 times square root of 3 is square root of 9. What is square root of 9? Okay, that's not a third, it's 3, right? Square root of 9 is 3 because 9 is a square number. So your final answer is square root of 6 divided by 3. So we have completely rationalized the denominator. How? Okay, look, the denominator is no longer a third, okay? It's an integer, right? So that's what we did. So if you look at the definition, rationalizing denominator means you get rid of the third part in the denominator by changing it into an integer. And the way it is done is you multiply the numerator and denominator by the denominator. Okay, or to be more precise, you multiply the numerator and denominator by the third part in the denominator. Let's take one more example. Okay, 8 divided by 3 root 2. So what is the third part in the denominator as of now? Okay, it is that root 2, and we need to get rid of that. And that's what is rationalization. Okay, so what we do is we multiply both numerator and denominator by square root of 2. Okay, now what do we have in the numerator then? We have 8 square root of 2, and in the denominator, we have 3 times square root of 4. Remember, 2 square root of 2 times square root of 2 is 2 times 2, 4, right? Square root of 4. Well, what is square root of 4? Square root of 4 is 2. So basically, the numerator stays as it is, 8 root 2. The denominator can be split as 3 times 2. Square root of 4 is 2, right? 3 times 2. Now you can cancel or you can divide 8 by 2, right? Numerator and denominator. And you are left with 4 in the numerator because 2 goes into 8 4 times. So your final answer is 4 root 2 divided by 3. Now, have we rationalized the denominator? Yes, we have, because there's no longer a surd in the denominator. If you look at the denominator now, it's a proper number. It's an integer, 3. We no longer have the root sign. So we have rationalized the denominator. Okay, this is called the process of rationalization. Well, that's the end of this session on surds. I hope you understood the three things that we learned in today's session. First, we understood what are surds. Then we understood how to simplify surds. And finally, we learned about some calculations on surds, including multiplying, dividing, adding, subtracting, and the last bit, which was called rationalization, where we got rid of the surd in the denominator. Right? I hope you enjoyed the session. I enjoyed it bringing it to you. Thank you.